Illustrating point in interval estimation. An estimator is a rule usually expressed as a formula that tells us how to calculate based on information in the sample. The word estimate does not suggest that we adopt the approach. Let us guess the mean value is, but rather, that value is carefully selected and the degree of confidence which can be placed in the estimate is given in addition. Two types of estimator. Number one is point estimator, which can be represented by just a point, and interval estimator from this point up to this point. The value that can be computed will be in between these two intervals or this interval. Point estimation. A point estimate uses a statistic to estimate the parameter at a single value or point. The rule or formula that describes the calculation is called point estimator, and the resulting value is called point estimate. Interval estimation. An interval estimate specifies a range within which the unknown parameter may lie. The rule or formula that describes the calculation is called interval estimator, and the resulting pair of numbers is called interval estimate or confidence intervals. A confidence interval denotes a range within which the parameter might be found, and the level of confidence that the interval does contain the parameter. Point estimation. In point estimation, the objective is to calculate from the sample data a single value that is most likely close to the unknown value of the parameter. The available information is assumed to be in the form of random variable sample x sub 1, x sub 2, x sub 3, up to x sub n, of size n taken from the population. We are interested in that the single value computed from the sample data that would reflect the value of population parameter as closely as possible. The difference between the estimated value of the statistic and the true value of the parameter is called error of estimation. Okay, kapag nakuha natin yung value ng statistic, again, statistic is from the sample. We're pertaining to the sample, and then the population or the parameter is we're pertaining to the population. So their difference will be called as error of estimation. This error of estimate is actually the standard deviation. Note that error of estimate is also the standard deviation of the estimators, which indicates the extent of variability in the distribution of the estimators. When we estimate a population mean from a random sample, the most intuitive estimator is the sample mean. X bar is equal to x sub 1 plus x sub 2 up to x sub n all over n as introduced in your junior high school mathematics. So point estimation of the mean, we have here estimator, or that is just simply our sample mean. And for the standard error of the mean is we have this S is for standard deviation of sample. Before, we're dealing with this symbol, but this one is the standard deviation of the population over square root of n. The following observation were the numbers of shares traded on the Philippine stock market in 100s. If we want to estimate the mean number of shares traded through the year, we would naturally calculate the mean of the sample observations. If we employ the estimator, we have x bar, we get the result x bar is equal to 40.96, which is called point estimate, or simply an estimate of mu. Now, to determine the accuracy of this single value, we shall calculate the extent of variability in the distribution of the estimator, the standard deviation, otherwise known as the standard error of the estimator. Calculating the standard error of estimator gives this formula, standard deviation of the sample over square root of n. But I'm going to teach you how to calculate the standard deviation of the sample easily. Now, you have to get your phone. If you have Excel on your phone, this is how you're going to do it. Okay, suppose that you've already have your data on your Microsoft Excel. All you have to do is press FX, then find statistics, then find standard deviation. We're gonna look for the standard deviation of the sample, right? So just standard deviation STDEV.S pertaining to the standard deviation of the sample. Then next is you have to press A up to the last part, up to this one. Drag it up to 80. Oh, I can't. Drag it up to 80. Again, from A1 up to 80. Then just press this one, the check mark. Then we have 22.7676462. Remember that 22.767622. That is where 22.7676 came from. So you can use your Excel in solving the standard deviation of the sample. Just encode your data on your Excel, then once again press FX, then look for statistics, then look for STDEV.S. Okay, 22.7676 divided by square root of 50 is equal to 3.2198. On your developmental activity, so we just have to answer point estimation of the mean. So we have the following data: the 5 pounds, 6.6, 4.6, 7.7, 7.9, up to 5.7. You have to first get the point estimate, or just getting your mean. Just add up all together, then divide it by 10, because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we will get 5.96. And to get 1.1067, just like what we did on the Excel, encode 5 all the given, I should say, and then get or look for the value of STDEV.S, then we will have 1.1067 divided by square root of 10, then that's gonna be 0.3400. So just answer this independent practice. We also have here another guided practice if you want to have a mastery of this activity. Then try to solve it using your Excel if you do have. Then for your independent practice, so we have a random variable sample of 25 applications for a credit card produced the following observations on the random variable X. The percentage of take-home pay being spent on installment bills are the following. Then once again, to find the point estimate, just get the mean. Then that's going to be your point estimate, and the estimate of the standard error of the mean, just get the standard deviation divided by square root of n. So that's it. So thank you very much for listening, and God bless you all.